Hey guys, welcome to the second lab. So this lab is going to be Atterberg limits. So these Atterberg limits came out to, they're meant for cohesive soils, so that's your clays, your elastic silts, certain fine-grained soils that have organics. So Atterberg limits, there are three main values that are important. That is the liquid limit, the plastic limit. These two are experimental. These are the two that we're going to find, and this it's the plasticity index is the last one, and that is again one of the values that we're going to use. So the purpose of this lab, think of the states of solids according to Mr. Atterberg. As you increase in moisture content, as this continues to go up, you have your liquid state on this side. You have a liquid limit in here. Have a plastic limit here in the plastic state. You'll have a shrinkage, right? You'll have a shrinkage limit. Which we're not actually going to find, so this is extra stuff in a semi-solid. And then over here, you have your solid state. So we're going to be hanging out over here. Obviously, soil for lava point, when that low moisture content is in that solid state. But when you have a cohesive soil, such as a clay, whether it be lean clay or fat clay, you might exist in this realm over on this side. So the point of this lab is to find this plastic limit, find the liquid limit. Plasticity index, Pi, super easy calculation. It's just your liquid limit minus your plastic limit. There are other variables such as a R value and different ways to calculate these things in the lab manual and in the STM, so we are not going to worry about it. So the only things that you need to calculate are these three pieces, as well as the moisture contents of each of them. And I believe that is it. All other calculations that we're going to be doing are going to be with are going to be graphical methods. So do not use the long equations that are in there. So the way it's going to work, there's my eraser. So instead of trying to talk about the procedure, it would be a lot easier if I just did it when I get to that point in the video. So I'm not going to talk about the procedure right now. What I'm going to talk about is how to get these values. So what is it we're going to do is we're going to go through the procedure, and I'm going to be adding moisture all the way through with as I run my liquid limit. And what we're going to end up with is a bunch of points. So let's get a blow count. So I guess I do have to talk about the procedure a little bit. So I'm going to have this little cup. I'm going to create a line between it. And basically what I'm going to do, so I have clay over here, clay over here. This will make sense later. But as I basically drop this cup from a standardized height every time, eventually it's going to come and meet in the center. Every time the cup drops, it's called a blow. Right? So I'll have different blow counts. So in my table and my raw data, I'll have different blow counts, and for each one, I'll have to calculate the moisture content. So 15%, 30%, 45%, right? So what's going to end up happening, I'm actually going to change that to 25%. I'll tell you why in a second. You want to pause real quick? So just talk about the procedure just a little bit. Basically what I'm going to do for my liquid limit, the first test I'm going to do is I'm going to add moisture until I try and reach that liquid state. And what I'm going to do is I'm going to put my sample in this little cup that's on a lever. So, and this will make a lot more sense when I actually, after you watch the video of me doing it. But so I'm going to put my soil sample in this little cup. And this cup is going to have a standardized drop height. And what I'm going to do is I'm going to take a little section out of the center and remove it so I have soil, soil. And I'm going to remove that bit, and then every time I bring the cup up and I drop it, eventually, after a certain number of blows, after a certain number of drops, it's going to come here to the center, right? It's going to meet. Once it gets to a certain size, I'm going to say it's done. There's a bunch of equations in lab manual about how different ways to calculate liquid limits, as well as in the ASTM and in the ASTO that I provide with you guys, but do not use them. There's a much easier graphical way to do it. The graphical way is what I'm looking for in a lab report. And what that's going to be is we're going to have our blow count down here and moisture content up there. Okay? So moisture on Y, blow on the X. What the raw data is going to look like is a bunch of different blow counts and then a bunch of moisture contents. Your job is going to be to plot them. So if I were to say 15 blows, 20 blows, 25, 30, and a bunch of different moisture contents, 30, 35, 40, 45, 50. So we'll say that these are moisture contents, these are our blow counts. Okay? The more liquidy that our sample is, the less blows it'll need to come together. If you think about that, that kind of makes sense, right? So up here at 50 blows, or sorry, at 50% moisture, it was only 15 blows. 45 is 20, 40 is 25, and 35 is 30. Okay? Notice that this is a downward sloping linear line, as it should be. What your job is going to be is to take the data, plot it, plot this line. It won't be perfect, but it should be pretty close to linear. Okay? Your liquid limit is at 25 blows. So you guys can try to use the empirical formulas that they give you. The formula is just to calculate this based off of 1. But the much more accurate way, especially if you can get exactly 25, is to come up here to 25, bring it over. Now, if this isn't 25, it's 26 instead, then you can just look at the formula of this line. Y is equal to, negative mx plus b, whatever it may be. Figure out, your x is going to be 25. And you can figure out exactly where 25 is, since I don't have 25 on there, which is normally the case. So that is all we're doing for the liquid limit. Plastic limit is a lot easier. The plastic limit, all I'm going to do is I'm going to roll it until I'm going to take a clay sample. I'm going to roll it out, make little worms out of it until it's exactly 1/8 of an inch. And then if it crumbles right at 1/8, then that's the plastic limit. I'm going to do that twice, and that's going to be the moisture content of that is going to be my plastic limit. So that easy. What this is used for is calculating the plasticity index. So again, this equation right here, and the purpose of it is for classifications. So I know you guys have seen this in class before. This is my U line, my A line. I do want to see your guys' classification on this. If you want to include this guy in your attachment section, you can. Just make sure you reference where you got it from, but I do not expect you to be able to come up with calculations for the U line and A line. But just make sure I get this right. My liquid limit is down here. Plasticity index is up here. So for whatever my liquid limit and my plasticity index comes up being, I'm going to come over here, I'm going to plot it. Okay? Whatever the section is, let me see the line, that. Whatever the section is for each one of these zones, there's another one, these right here. Whatever zone you have to land in, that is the classification of your fines. So that is the purpose of this. Again, I do expect to see the liquid limit and blow count graph in your guys' lab reports. I do want to see at least this table in the attachments. You don't necessarily have to plot it, but you do have to give me the classification of the fines that I have based off of this, and all that information is in the files that I gave you. Again, like last time, you have the ASTMs, the AASHTOs, and lab manual. The lab manual is based off the ASTMs. You guys can follow whichever one you want. They will all be very similar. So I think that is it for what I got to give you. So that'll be that, and we'll go do the lab. Alright guys, so welcome to the Strata Soils lab. So the percussion cup is this guy. So what I'm going to do is I'm going to take my soil sample after it's about the consistency I want it to get to, and in this, it basically drops, and I'm going to go until it's at a certain point. Now for this procedure, the first step is going to be to bring it through the number 40 sieve. So this is called a sieve. The reason why it's number 40 is for every linear inch there is 40 openings, 40 holes in every inch. So I took my soil sample. This is a clay sample, so it is a cohesive soil. And I'm going to put it on this. I can get it out. I'm going to see if I can get the sample through here. Again, number 40. That should be in your procedure. It is in both the ASTM, the AASHTO, or all three, the ASTM, the AASHTO, and the lab manual is based off the AASHTO. Or sorry, the lab manual that is based off the ASTM, excuse me. So I get some of it through, put it back, put it up again. I'm making sure not to break any rocks, but I do want to break down these clay particles, or the clay chunks into clay particles. Again. Open this up. That is what my sample looks like underneath, and that's what I'm going to be using. Take my container. And it basically just feels like a very fine powder. That's all this really feels like. I'm going to try and get a little bit more of that one more time. This all up. Put it down. And I am trying to do this as fast as I can, just for the video length and for you guys' sake, because I know that it sucks watching labs. I have taken a lab online, and like you guys, I'm probably just waiting for the data, not paying attention. Okay, so open it up. Should be about plenty. You got a little piece of organic, pull out. So now what we're going to do, we're going to add a little bit of water. That might be a little too much, but we have to find out. And mix. Now, ideally, what I'm trying to get to, just to let it soak in, is about the consistency of peanut butter. That is not a technical definition, but it is a good starting point. You got it nice and mixed. Now, it doesn't say this necessarily in the lab manual. If you look at the ASTM or the AASHTO, and I believe they might have different lengths of period that it needs to sit, but it's supposed to sit for, I believe it's at least 2 hours according to the ASTM. So that way just soak through, because clay, if you think about it, doesn't like to give up its water. Clay has a very low permeability rate, and it's part of the reasons why it's problematic on job sites. So just to get it, make sure it's all nice and uniform, what I'm going to do is I'm going to put a cap on it. I'm going to let it sit for probably the next 2 hours. Whether that's the correct amount of time or not, it doesn't really matter because it's the lab and I'm not actually going to be reporting any of these results to any Strata clients. But I am going to let it sit for a little while, and I might also add more before the next video. Until then, we'll wait.